So this is from the Business Maths 1 summer paper, and it's a probability distribution question. Now, a bank knows that on average 15% of loans to SME, small medium enterprise companies will default. For a loan book of 12 SME loans, find the probability that exactly 2 will default, at most 1 will default, and at least 2 will default. First off, we actually have to decide what probability distribution this is. So what we're going to do is pick out a few remarks in the question, and first off, exactly 2, at most 1, and so on. Like, you cannot have half a company defaulting, or half a loan defaulting, or 1.25 loans defaulting. You only have 1 loan defaulting, 2 loans defaulting, 3 loans defaulting, and so on. So it is a discrete distribution. That's the first remark. It's a discrete probability distribution. So the next thing we have to do is decide which probability distribution it is. So let's look at the clues in the question. So first off, we have a probability of an event, an occurrence. And so it's the probability that there will be a default. Okay. Now, also what we're going to see is that there is a probability of this occurrence, and it is 15%. And there is a number of n trials, or sample size of n, and that is sample size 12. So essentially what we're saying is this is a binomial distribution. A success is what we call the event of interest, and that is a default. A bit counterintuitive that we call a default a success, but there you go. The probability of a success is 0.15, and the number of trials, or in other words the sample size, depending on what the context of the question here, is 12. So we're going to probability P is 12. Let's write that there in green. Or sorry, N is 12 and P equals 0.15. So we're going to say that this is a binomial distribution question with N equals 12 and P equals 0.15. Now what we're going to do is go to the back of the exam paper and see that we can use this formula here. We know it's binomial, so we can use all this information here. We're told the mean, we're told the variance, but also we're actually also told how to compute the f of x is the probability mass function, probability density function, depends on what your the context. That essentially means here f of x it essentially means f of x. X is a number. That means the probability that the number of defaults will be x. Okay, I'm going to use small x there. So for example, f of 2, number of defaults equals 2. Okay, x is the number of defaults. So what we're going to do now is use that formula here. Now we've got all the pieces of information that we need. We have n, we have p. In fact, we have everything we need there. We also have this operator over here. This is binomial coefficients operator, the choose operator. What we're going to do is use that actually for the first question. And so we're interested in here if exactly 2 will default. So this is the probability of x equal to 2, or as we would also write it, f of 2. Okay, so let's compute that. So in this case, small x is going to equal 2. Capital X is number of defaults there, so I have capital X and small x. So f of 2, what we have to do here is first off compute this expression over here. Let me write it out. And remember, n here is 12. So n of small n, choose small x. This is how many ways can we choose x from a size, a group of x items from when there's 12 to choose from. That is using the numbers we're using here. 12 choose 2, and that's equal to 12 factorial over x here is 2, so 2 factorial. N minus x is 12 minus 2, that's equal to 10 factorial. So I'm going to come back to that now. 12 factorial can be written as 12 by 11 by 10 factorial. Okay. 2 factorial is 2 by 1. And 12 minus 2 factorial, let's write that in as 10 factorial as well. And that is equal to, essentially what I'm saying is 10 factorial and 10 factorial cancel out. So what we have here is 12 by 11 divided by 2 by 1. 12 by 11 is 132. Divide that by 2, and we get an answer of 66. Essentially, just do a little bit of calculator work on this part here. Very simple calculation. Now that the rest of it is not being used. So that's the first part. So we have calculated n choose x, which is 12 choose 2, 66. Now the rest of the calculation is pretty simple. So I'm going to go on to a new slide here. So exactly 2 will default. F of 2 is equal to 66, which is this part here. And then p to the power of x. Now remember that x here is equal to 2. So we have, and p is p is going to be 0.15. X is 2. And n is 12. We've already calculated that part. So p to the power of x is 0.15 squared times n to the power 1 minus p. 1 minus p is 85%. 1 minus p equals 0.85. Okay. Times 0.85 by n minus x. N minus x is 10. 12 minus 2. So what we have now here is a very straightforward bit of calculator work. And let's work that out. It is 66 times 0.0225. Okay. Times 0.85 to the power of 10. Working that out in your calculator, you get I get 0.1969. Working out all of those together, you should get an answer of, let me check this now, 0.2923, just to round it to so many decimal places. 0.2923. So that's the answer to the first one. Probability that exactly 2 will default. It's 0.2923, or in other words, 29.23%. Okay, so now we're going to do the next one, and it's what we're asked for is exactly, no, we're actually asked for at most 1 will default. So this is interesting. So the probability of at most 1. So the probability of x less than or equal to 1, that is equal to the probability of x equal to 0 plus the probability of x equal to 1. So just the wording here is very important. At most 1 will default. So that is the probability of 0 defaulting, no defaults, or 1 defaulting. And because they are mutually exclusive events, we can just actually add the probabilities together. So what we have to do here is calculate f of 0 and f of 1, which is equivalent. That's actually how we might write these also, those probabilities also. So f of 0, what we have to do is actually find out the n choose 0 first off. I'm going to change color here to black here. So 12 choose 0 is 12 factorial over 0 factorial divided by, what's n minus x? 12 minus 0 is 12 factorial. So what we have here are the 12 factorials cancelling out. So we just put a 1 there. So we have 1 divided by 0 factorial. Now, just as important remark here, 0 factorial is equal to 1. Okay, it's not equal to 0. A lot of people make that mistake. So what it's actually what we have here is 1 divided by 1, and that's just equal to 1. Let's do the other one here as well. 12 choose 1. That's equal to 12 factorial over 1 factorial times 11 factorial. We can write 12 factorial as 12 by 11 factorial. So we have 1 factorial times 11 factorial in the denominator. Let's write that in there properly. The 11 factorials cancel out. So what we have there is 12 divided by 1. Sorry, let's just catch up there. So that's equal to 12 divided by 1. And that's just equal to 12. Okay. So we have 12 choose 0 and 12 choose 1, and they are 1 and 12 respectively. So we can move on to the next, we'll just move on to the next slide here now. So let's just continue on with what I was doing there. This is actually exactly 2 will default. That's the next one. So probability of x equal to 0 is equal to 12 choose 0 by 0.15 to the power of 0 by 0.85 to the power of 12. And we know that that is equal to 1. Anything to the power of 0 is also equal to 1. The 15 to the power of 0, that's just 1. So we just have to calculate 0.85 to the power of 12. And that is equal to 0.1422. Probability of x equal to 1 is 12 choose 1 by 0.15 to the power of 1 by 0.85 to the power of 11. So this is a slight bit more complicated. That's 12 by 0.15, 0.85 to the power of 11. Working it out in your calculator, you should get a number like 0.1673. And that is, I make that out to be 0.3012. So the probability of x less than or equal to 1 is these two numbers combined, 1.422 plus 0.3012, and that is equal to 0.4434. So the answer to the second one is 0.4434. Okay, make that a bit clearer there. So the last one here is actually exactly 2 will default. Now this one, that means exactly at least 2 will default. Sorry, at least 2 will default. So the probability x greater than or equal to 2, and that's equal to the probability of x equal to 2 plus the probability of x equal to 3, all the way up to the probability of x equal to 12. Lot of work there. Too much work. What we can use here is the complement rule. And what is the complement of probability of x less than or equal to or greater than or equal to 2? Probability of x greater than or equal to 2. What's the opposite of that? What outcomes are not listed? Would not be listed here. It is actually the complement of at most 1. These are complements of each other. Okay, at most 1 will default, at least 2 will default. These are two mutually exclusive events, and they're also complements. So what we can say here is that the probability of at least 2 defaulting is 1 minus the probability of at most 1 defaulting. So the answer to this one here, I'll actually just write it here in green, is 1 minus 0.4434, and that is equal to 0.5566. So the answer to this last one, at least 2 will default. The answer to that is 0.5566. So that ends this presentation on the binomial distribution. And again, the answers to the last two there, 0.4434, this one down here, and the third one, 0.5566. That's at least 2 will default. That ends the presentation.